Hi viewers, welcome to LMS Solution. Today we are going to see about the new MPPT algorithm, nothing but Drone Squadron Optimization. Here you can see that this is the simulation model for Drone Squadron Optimization. If you want to know about the more detail on Drone Squadron Optimization MPPT, then you can go to this paper. This paper is published in Neural Computing and Application about Drone Squadron Optimization. Is like the command sender send the sum of team of drones in the landscape based upon the data gathered from the drone. It won't be processed in the command sender, and then based upon that, it will send some firmware to the drones to get the detail and process the detail. That kind of detail that been based upon this drone control. They implemented some optimization algorithm, nothing but drone squadron optimization. The same concept. Here we are using for MPPT algorithm also. Based upon that Drone Squadron optimization concept, here we implemented that MPPT nothing but a maximum power point tracking algorithm for a PV system under partial shading condition. For that, here we have three panel, each panel having around 83.28 watts, and then is connected in series. So three panel connected in series. Three panel will be operated at 25 degrees Celsius, but the irradiation of the three panel will be operated at a different level in order to create that pulse shading effect. After that, this the combination of these three panel three cells when be connected to the load via this boost converter to boost the voltage. From here you will get around 30 volt to 60 volt, 60 to 80 volt in the load side, and then here we are providing the irradiation condition for the three set of PV cells or PV panels. So, and then here we are measuring the voltage and current of the PV panel, and then when we process via Drone Squadron Optimization MPPT auto. When go inside this code inside that Drone Squadron Optimization MPPT, first we need to send the different duty cycle, and then we have to collect the voltage and current, and you have to find out the maximum power. From that maximum power, you have to find out the local best for that specified drone, and then global best of the specified drone. Based upon that, we have to apply that drone squadron optimization algorithm. This is drone squad optimization algorithm. It will be find the optimal duty cycle based upon the power of the people. Finally, optimal duty cycle going to be sent to that process via PWM generator. The duty cycle taken from that Dragon Squadron optimization is going to be processed via a PWM generator. So the PWM generator going to be generate the duty cycle. Here we will get that PWM pulse. So this PWM pulse going to be used to for control this IGBT in order to extract the maximum power from the PV panel during partial shading condition, as well as to boost the voltage from a low level to high level according with the load requirement. Before that, I am going to explain the details here. Here I am going to fix irradiation. So same kind of PV panel is taken here. Here I am going to fix the irradiation is equal to 1000, and then here I am going to make 300, and then I am going to simulate this one. So here you will see that the three panel operated three different level of irradiation. Then here you will see that the IV and the PV characteristics of the considered three panel. From that you can see that they have three different kind of peaks. Here you can see that this two will be considered as a local peak, and then this peak will be considered as a global peak. This global peak should be tracked by means of maximum power point tracking algorithm without trap in that local peak point or local peak power. For that only, here we are using a Dragon Squadron optimization. Here you can see that the global peak power is around 104.5 watts. So here I am going to click this one. It have only 71.91, and this one having 83.48. From comparing this three peak level, this is having highest level. This is going to be considered as a global peak point. This global peak point need to be extracted by means of optimization algorithm. Here I am going to fix the same kind of condition, and then I am going to simulate the system, and then you have to check the result of the PV power. What kind of PV power we are getting, we have to check. You can see that PV power is nearer to that maximum power point. Now we can see that it reaches that maximum power point level. This is around 103 or 104. So it will reach that it extract the maximum power according to the partial shading condition of that PV panel. And then this is a load power. This is a PV voltage, this is load voltage, this is PV current, this is load current. This is for particular condition. Now I'm going to change the irradiation condition to 600, and then I'm going to submit this model and below to check them. I did here you can see that here only two irradiation levels. One is 1000, another is 600 for this two PV panel. That's why we are getting only two peak points. So in this peak point, this will be local peak and this will be global. Here you can check the peak point value. Peak point power value is around 158. Here it will be 71.79. So we need to extract this point from the MPPT algorithm. So here I'm going to change to 600 and then I'm going to execute the model and then we will check the details. Here you can see that it try to find the peak point. It is towards to that peak power point and it take around I think 1 second. Now you can see that it is needed to that peak power point. For different irradiation level condition also, that Drone Squadron Optimization MPPT extract the maximum power from the PV panel under a partial shading condition. Here you can see this PV voltage, load voltage, and then this is PV current and load current during that partial shading condition. So this is a working of Drone Squadron Optimization MPPT for PV system under partial shading condition. Thanks for watching the videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you so much. Bye bye.